We're told we have a finite geometric sequence. So that's a geometric sequence means that you're multiplying something each time and it ends. It doesn't go on forever. They want us to find term 2 and term 6. Now, what are the tools that we have? We know it's a geometric sequence. We know on our formula sheet that the formula for each geometric sequence looks like this. What do we know and what don't we know? We don't know r. So if we want to use the formula for anything, we probably need to find r. So now the only way we could find r using the formula is if we could put in things for everything else. Do you see that we know what term 1 is? Term 1 is 7. We know term 5, so if we use term 5 for the general term, we would have to plug in 5 for n. So if I plug in 567 for term 5, term 1 is 7. I still don't know r, but since I know term 5, this will be 5 minus 1. And now it's just a matter of solving for r. So if I divide both sides by 7, I get 81 equals r to the 4. Do you know how to use your calculator to get rid of that 4 to get r all by itself? Okay? What's the opposite of putting something to the power of 4? Well, what's the opposite of putting something to the power of 2? Square rooting. So to the power of 4 will be the 4th root. And just like square roots, any even root, when you take the even root of both sides, you have to remember it could be positive or it could be negative. Because 81 is 3 times 3 times 3 times 3. 81 is also negative 3 times negative 3 times negative 3 times negative 3. 4 negatives would all cancel each other out and become positive again. So we have 2 possible answers for r. Solving it this way. Okay? Now, what does that mean term 2 is? If you took term 1 and multiplied it by positive 3, it could either be 21 or negative 21. And if you took term 5 and multiplied it by 3, or negative 3, you would get 1,701 for term 6, or negative 1,701. Then for part B, it says the last term. Question? R is the common ratio. So R is what you're multiplying by each time. So anytime you have a geometric sequence, that's one sequence where you multiply each time. And then we use the letter R because if you divide any 2 terms in a row, you get the same number. So it's a common ratio, and that's why we use the letter R. So in part B, it tells us the last term is 45,927. Algebraically, what does that tell us? We know there's a term with some number here that's equal to 45,927. We just don't know which one it is. So we will use Tn to represent it. Okay? Again, this is sometimes confusing for students. Right now, we're using Tn to represent the last term. Sometimes we use Tn in the formula to represent the general term. Okay? In this question, we use Tn to plug in term 5. So Tn can be any term we want, and we can use it in different ways. Sometimes we need it just to make our formula. Sometimes when it says something like a last term, we're going to use that as our last term, but we don't know what n is, even though we know what Tn is. How does this work in our formula? Well, now we can say that there's some term that's 45,927. According to the formula, term 1 is 7. R is 3 or negative 3. And then here, we would have n minus 1. How do I solve for n? Well, if I divide both sides by 7, go to my calculator, 45,927 divided by 7, I get 6561. And it's not until you get to grade 12 pre-calculus that we'll show you an algebraic way to do this. In grade 11 pre-calculus, they're going to say, you now know that three to the power of something has to equal 6561. First of all, since this is positive, and this could be positive or negative, does it make sense that your exponent has to be even? Which means that n, because the exponent is n minus 1, n has to be odd. So as far as guessing and checking, you could go to your calculator. You could start with, okay, let's say n is 5. Is 3 to the 4 high enough? No, I get 81. What about 3 to the 6? 729. What about 3 to the 8? 6561. 3 to the 8 equals 6561. So n has to equal 9. There are 9 terms in the sequence. Okay, I'm going to give you 5 minutes to try questions 8, 9, and 11.